if you put something in the beam, now you can see the beam. And why can you see it now?
Because it's hitting something and scattering.
Yeah, because it's hitting something for those photons to bounce off of, and so some of them get scattered towards your eye so that you can see them. So that's one of those things that shows up in movies a lot.
Yeah.
You know, they'll have like a burglar alarm system with lasers, and then Tom Cruise will come out and put on the funky glasses, and now he can see the beams and you know, dance around them and not breaking any beams. That gonna work? That ain't gonna work.
So you couldn't have missed beams like that?
No, that was a visible light beam right there, and you guys couldn't see it. So why do you need even funky glasses? You know, if it's an infrared light beam, and you put on the glasses that make infrared visible, you're still not going to see it, because the light's got to scatter and go towards your eyes. So just putting on the special glasses isn't going to cut it. You've got to be able to have something that will scatter and send the light in all directions. Yep.
But doesn't Tom Cruise usually have smoke too, and then that would scatter it?
Well, let's talk about that.
Tom Cruise doesn't.
Suppose you're the super spy, and you've got to break in and steal whatever it is Tom Cruise is after. He's always after something. And so, if you put smoke in the room, will that make it so that you can see the beam? Yeah, that could work. But what's the downside on that? Your receiver at the end, where that light is shining in, how much light is getting there now that you're deflecting some of those photons away because it's hitting smoke? Yeah, your receiver there is going to show a drop in intensity because not as many photons are getting there anymore because they're getting scattered by the smoke. So you're probably going to trigger your smoke or your burglar alarm system that way as well. So what about the one where he comes in and he's got a mirror and he carefully points the mirror over at another mirror and then to the detector, and so that he creates a pathway that he can walk through? Is that going to work?
It still look like it'd go off.
So it's going to be one of those theoretically could be able to do, but in actuality, in breaking the beam here and breaking the beam here and then making it come back and connect here, you're going to have a detection time there where the beam is broken, where the receiver's not seeing any light. You know, you can't put both of those mirrors in place instantaneously so that the light beam continuously hits on the mirror without ever being deflected. Maybe you could use a beam splitter, which is a series of two mirrors. One of them is partly mirrored, the other one is totally mirrored. So the beam could come through, hit the first mirror, half the light goes that way, half the light goes this way. The light that goes this way, then you could reflect over and hit your source, and then the other, you know, but again, you still end up the same thing like you did with the smoke. Some of your light is not making it to that detecting surface at all anymore, and so depending upon how sensitive the electronics are, there's going to be a drop in intensity.
But if you could like get into the circuits where you're not actually working with them, but where you like hit it so it's off for a moment, you have control of it, but you can't really hold that, so then you have time to place it.
Well, if you hire the computer whiz, because they always have to have a computer whiz on their team, then the computer whiz hacks in and takes over the electronic stuff so that Tom has a chance to change light. But yeah, you're right. But there are multiple parts to the system, and sometimes the stuff they show on the movie is just isn't all that accurate.
What about, have you seen the zoo, Mission Impossible?
I don't know. There are a couple of them around, and I don't remember which
Ghost
ones are
Patrol.
which.
It's like stationed in Dubai mostly.
Doesn't ring a bell. I probably haven't seen that one.
Okay, well there's this screen where they set it up and like it moves the guy's eyes, and so like it's supposed to be invisibility, like it's taking a constant picture of what's behind it that the guy should see. So it makes it look like it's totally invisible. So they can walk up the hallway. Do you think that would work?
So they've got a person, and they're feeding him light that's like a picture of a hallway without a person in it.
Yeah.
So how do they get that light into his eyes?
Because like their screen, I think can produce any amount of light, but then it's producing what the camera that's not seeing them because it's behind them is collecting and re-amplifying it.
I'm not getting it. I'd have to see it. I'm the idea that if you can take the light that normally would hit you and scatter and go somewhere else, if you can redirect that light and get it to a person's eye, you know, how we started the whole discussion of how could you make something invisible, that is one of those ideas that we talked about, and maybe that's what that part of the movie is based on, but I haven't seen it enough to say that that's what they were doing. What they were doing. Did you have a hand up? All right, let's move on. Let's go down to number 18. Which requires a physical medium in which to travel? Light, sound, or both? And explain. Person number 7. And explain.
Sound is a longitudinal wave and it travels through anything in the air by pushing the air molecules up against each other until it reaches your ear.
Okay.
But light can travel electrically back, so it doesn't have physical.
Yeah. Sound is a mechanical wave. It requires a medium in which to travel. So like the air molecules have to vibrate, or sound traveling through the table. The wood molecules have to vibrate and shake each other. But electromagnetic waves do not require matter. They can travel through a vacuum. So sound is mechanical. You gotta have a medium for mechanical waves. Number 9. Do radio waves travel at the speed of sound or the speed of light or somewhere in between? Go ahead and talk to those. That was number 19. Person number 1 is up.
The speed of light.
And explain.
It's an electromagnetic wave, so it's going to travel at the speed of light. And I mean, even though we've got radios, they detect the wavelength or the waves, and then they can produce the sound out of here, but that doesn't mean that it's sound.
Okay. So how do you explain to somebody who's never seen a radio before that the sound you're hearing is originating in a station on the other side of the state? And they think, boy, that person must really talk loud.
It's magic.
Well, because the station is emitting the light wave, and then the radio is detecting it, and I guess you could say translating it into sound.
Yeah. The sound vibrations, that lower frequency is overlaid over the carrier wave, the light wave that we were talking about before, and it's that light wave that is actually being transmitted across the state, and then the changes in it, which is the data, get translated back into sound waves. And that's what the radio actually does. It converts the mechanical wave to electromagnetic, and then electromagnetic back into mechanical again. So let's go to number 21. What are some similarities and differences between radio waves and light waves?
Because we can't put sound on light.
Radio wave.
Tired of that? It must be pleasant.
Similarities in speed,
Person number 6 is up.
The similarities, they can both travel at the same speed in a vacuum. They can both travel through a vacuum. So those are electromagnetic waves, and then the differences, of course they have different wavelengths and frequencies, but then like their properties are different. Like the radio waves can have some interference from like if you're in like a valley or something. Like light has some like light can go through a table, but like if you had two stations, radio stations on either side, it can go through.
Okay, which is really a property of the wavelength and frequency. Again, the fact that you said that, you know, they have different wavelengths and frequencies, but the speeds are the same. So, and the interference, what they interfere with, are a function of what their wavelength or the frequency is. What if they had asked the question instead of about light and radio waves, what if they had said sound waves and light waves? Are there any similarities between sound waves and light waves?
Both waves.
What?
They're both waves.
They're both waves.
They both can transport both energy and information.
True.
They both have a fixed speed.
Sounds
I just,
I would agree with that. Now, the speed of light waves are, you know, hundreds of thousands of times higher speed even than sound waves, but they're still fast. I mean, compared to how fast I could run. Any differences? Speed,
it's actually.
different speeds?
How they pass through, space.
How they pass through space, somebody said how they go through a vacuum, what?
One's transverse and one's longitudinal.
Right, which is which?
Sound.
Longitudinal is sound.
Sound waves are longitudinal, light waves are transverse. Yeah. Good job. Let's talk about number 24. If you fired a bullet through a board, it'll slow down inside, and when it comes out the other side, it'll be traveling at a speed slower than it was when it went in. Does light then similarly slow down when it passes through glass and then emerge at a lower speed? Defend your answer. And it's the defense of the answer that I'm really interested in. Go ahead and talk.
Right.
It doesn't want the photon.
It has to be like the same.
I think it's like, well, it's the same bullet. Light wave, and it's a
light is light.
Right.
completely creating a new
It's
light.
not the same effect,
Or a
right?
new light, but still goes.
They say that like the light should re-emit is like the same frequency.
Yeah.
Person number 5.
I just, hold on, which number was that? I have the answer.
That was number 24.
Okay, no, it doesn't, it's not the same kind of deal, because the light still is moving at the speed of light when it emits the other, when the other photon excites inside the
Okay.
material.
So how could we simulate a more accurate simulation of the light photons passing through glass? How could we do that with bullets?
If you
Or could we do it with bullets?
shot a bullet from like a gun, assuming that it doesn't really slow down through like air, shot a bullet, and once it hits the glass, I guess you shoot another bullet, the same gun, and
What?
so the same speed, yeah.
So if all the way down the hall we put a bunch of targets, and by each target we put a person with a gun, and when somebody at the end shoots the first target, when that target gets hit, that person says, okay, that bullet is stopped, bang, and they shoot. And when that bullet hits a target and stopped, the person by that one says, okay, now that bullet is stopped, bang, and they shoot. Then the bullet that comes out the other side, is it traveling the same speed or a different speed as the original one that went in?
Different. Same.
Same speed. But the speed, if we take the average speed of the whole thing down the hall, the average speed of the bullets in the hall will be slower than the